So my name is Adrien Treuille, and I'm a professor at Carnegie Mellon University, and I'm going to talk to you about how knowledge creation is going to change over the next coming decades, and I think it's going to profoundly change. And the situation is actually not that different from computation. 50 years ago, if you wanted to get access to computation, you had to go to a university or a big corporation. You couldn't do it any other way. And now, as Sergey put so eloquently last night, we have more computation in each one of our pockets. The same thing is happening with knowledge creation today. The knowledge creation is dominated by big universities and large corporations, which create the world's theories and products. But I think that in the future, we're going to find knowledge creation spread throughout all of society and really generated by ad hoc networks of people on the internet. Okay, so what do I mean by this? Let me give you an example. Protein folding. Protein folding is one of the key challenges in biology today, and it's typically done in large universities on supercomputers. And a couple of years ago, some colleagues of mine and I set out to see if we could find a completely different model. So the protein that you see here isn't being folded by some supercomputer. Okay. It's being folded by an 11-year-old boy in upstate New York. And this is a game which we created called Fold It. And in fact, this boy is one of over 100,000 Fold It players around the world who are competing and collaborating to fold proteins. Let me give you another example. This is a nano-engineering interface that we came up with for a game called Eterna, which takes the Fold It idea, one step further. So what happens here is players design molecules, but then they select which molecules they think are best. And then we automatically synthesize these molecules and send back the experimental results to players, which scores their efforts, and in high throughput biochemistry. And the thing about this is that players are actually fantastic at this. So when we started this experiment, the players were not doing very well. They're the red dots there. To be honest, the computers weren't doing that well either. But through this sort of cycle of experimental feedback, over the course of 6 months, 30,000 non-expert Eterna players got better and better at nanoengineering to the point that their worst solution was better than the best computer solution. Okay? Even more excitingly, we've been able to ask the players how they're doing this. So this is a pattern which was unknown to science. It's highly predictive of whether or not an RNA is going to fold. Okay, so this is serious science. We've published Nature papers based on what these players have done. But this is just the beginning. And so I want to take this talk to extrapolate these ideas a little bit into the future. And the first thing I want to talk about is training. So both Fold It and Eterna were highly based on tutorial levels which taught people basically the biophysics required to solve these problems. And it's very interesting that we can do that. It's a whole other story. But what I want to concentrate on is that this has allowed us to filter through hundreds of thousands of people on the web and find those who are experts at these very esoteric tasks. And in the future, I can imagine that as grand challenges emerge, we can come up with games and puzzles that essentially exploit the skills required and find at a very fine-grained level people who are experts at these kinds of problems. And I'll tell you, the person who owns this network owns something very, very valuable, knowing all this expertise. The second thing I want to talk about is big data. So we all know that we're in the midst of the big data revolution, and it's very real. And the question is, what role do humans have to play in this type of computer science? And so to make this more concrete, suppose I gave you 1 million images, and I asked you to use them to train a computer to find an object in an image. So for example, find this tiger inside this image. This is the object recognition problem. People have worked for decades on this. It's devilishly hard. They've come up with all sorts of advanced techniques such as active classification, discriminative learning of relaxed hierarchies, multi-class boosting, self-paced learning, matched product belief propagation. Now, I'm not going to go into these now because I presume that you guys are familiar with all of this. But the point is that it doesn't actually matter so much which one of these you use, because it turns out that vastly more important than the machine learning algorithm you use is which features you extract from the data. It turns out that if you just look at the raw pixel values in an image, it doesn't matter what you do. You'll never discover this tiger in this image. So computer scientists and statisticians and economists work very hard to extract features from data sets from which we can then do machine learning. But if you look at what this player has done, he's essentially he's found a feature which we can use to discriminate RNA nanoengineering, right? And so when people think of crowdsourcing today, they typically think of simple image and pattern recognition tasks. But I think that this work presents a model in which large groups of people work with big data and lots of computation, actually, to solve problems at the limit of human knowledge. The final thing I want to talk about is rewards. So when we look at a game like Folded or Eterna, we have all these players which are designing these molecules, and we know exactly when every single molecule was designed. They're time-stamped. And by analyzing the data carefully, we can also tell who influenced whom. And we can use this to get a very fine-grained score for each player. And this isn't the coin-up score from, like, you know, the coin-up machine in your diner or something. You guys are probably too young to know about those. But this is a very, very fine-grained score that we can use for collaboration and competition. If you take this idea of score and turn it into the idea of money, all of a sudden we have a very fine-grained way of paying people for intellectual labor. And I think that this model can really upend the way that the economics of intellectual labor today. So let me give you an example. Why is it when you go to Ford, do you buy an entire car, right? Why isn't it that you just buy thousands of different components from different individual makers and pay someone to assemble them into a completely custom car? Okay? So this question is basically, why do corporations exist? And it was solved in the 1930s by an economist called Ronald Coase, and the key is transaction costs. So a corporation seals off a bit of the economy from the rest of the world, and within the corporation, the transaction costs are extremely small. And the transaction costs only occur between two corporations or between corporations and people. Unlike Mitt Romney, I actually distinguish between those two relationships. But the key to the kinds of models that we are developing is that they drive these frictional transaction costs to zero for very, very fine-grained units of labor. And I think that this is going to have a big impact. So already my work has shown that we can do this for real scientific discovery. A similar thing has been going on for about 2 decades in the open source software movement. But I think this could be applied to product design as well, right? The next Steve Jobs could simply dream up the iPhone, and then the rest of the design process could be carried out by automatically discovered experts in networks all over the world. Why can't we apply these ideas to societal grand challenges like global warming? I think that we can imagine very, very large groups of people with myriad different expertise working together on the internet to solve these, and a society that solves these problems together might be more likely to implement the required changes together. Okay, so the kind of platform that I'm imagining for the future is a platform which will enable us to identify expertise in large groups of people across the internet. It's going to allow us to engage these people in complex big data tasks. And it's going to allow us to remunerate them at a very fine grain for the work that they're doing. But this isn't some kind of, you know, bleak future of human automata, actually. If we sort of flip this around and look at the users of the system, it's really find me, engage me, and pay me. And I think this is a future which will enable people to discover skills and then contribute much more richly, deeply, and efficiently than is possible today.
Let us define X. X is a solution to a seemingly insurmountable problem. Like climate change or cancer, one that affects the world. But what if we redefine X as a challenge, an opportunity for radical thinking, a chance to light up the world with breakthrough ideas and cutting-edge technology, the stuff of science fiction that just might fly after all. Solving for X requires wonder and imagination, and the vision to build seemingly impossible solutions to the world's biggest problems. Solve for X. Moonshot thinking.